Hello and welcome. My name is Paul Naji, and I wanted to welcome you to our first grand rounds of the year. This is an important function that we have within our informatics program to expose our students to the latest activities and research advancements in our fields. And I wanted to welcome all of our new incoming students this year, as well as our returning students and our faculty and staff across Johns Hopkins, as well as our many colleagues joining us from other universities, as well as members of our general public. And so this is a really important function for us, and you are welcome. If you've taken any one of my classes, you will know I love questions. And so we are encouraging you to ask questions during this live webinar. To do so, please look at the Zoom webinar capabilities in the Q&A function, or you can submit during the lecture series. We'll compile them and make sure Chris has an opportunity to be able to answer them at the end of the class. This lecture provides continuing medical education, and so that you can, this is available for people to have medical education. Next slide, please. Thank you. Today's activity code is 31012. Please text this to 443-541-5052. So if you haven't yet gotten your registration for getting CME credits, and this is your first time, you need to email your JED email address to the following phone number. Oh, sorry about that. And when that happens, you'll actually be getting a text notification, and you'll have to pair your account, your JED, to your cell phone. And then once you've done that, you can text the activity code to that number, and then that will give you register you for the CME certificate credits awarded. And if you need to set up a new profile, please go to hopkinscme.cloud-cme.com and click the sign up now. We also will be following this lecture on Twitter, so please join us at JH and join in the exciting conversation. And today, to introduce our grand round speakers, we have Dr. Diego Martinez, who's an assistant professor in emergency medicine, and he will be leading our grand round seminars this series.
Thanks, Paul. Hi, everyone. Welcome. We are very excited today. My name is Diego Martinez. I'm a faculty in the School of Medicine, and I'm here today with Dr. Christopher Chute. Dr. Chute is the Bloomberg Distinguished Professor of Health Informatics, Professor of Medicine, Public Health and Nursing at Johns Hopkins, and the Chief Research Information Officer for Johns Hopkins Medicine. Dr. Chute received his medical training at Brown and doctoral training in epidemiology and biostatistics at Harvard. He is a board certified in internal medicine and clinical informatics and an elected fellow of the American College of Physicians, the American College of Epidemiology, HL7, the American Medical Informatics Association, and the American College of Medical Informatics, as well as a founding fellow of the International Academy of Health Sciences Informatics. He is presently the PI on a spectrum of high-profile informatics grants from NIH, Spanish Translational Science, and he is a co-lead in the National COVID Cohort Collaborative, N3C. With no further ado, please, Christopher, you have the control.
Thank you very much, Diego. I'm grateful for such a great introduction, and I'm also privileged to be the first speaker in the series this year. It's always gratifying to come back and share what we're doing with this community. So with that, let me talk about the National COVID Cohort Collaborative. Let's see, we'll get through these intro slides to there. And next slide. What it is a collaboration between and among CTSA organizations across the country to create a centralized, secure location where data about COVID patients can be aggregated for analysis and sharing. It's a partnership not only with the CTSA program, but with many of the Common Data Model Network communities such as PCORNet, Odyssey Act, and Trinetics, who all have contributed enormously to make this possible. Next slide. You might ask, well, what's different about N3C relative to other environments such as PCORNet, ACT, Trinetics, and OMOP? The reality is you can ask very useful questions to what we call federated networks like OMOP or ACT or PCORNet. For example, you can say, does drug X do harm or does it do good? And it's quite practical and useful and effective to get responses to questions like that at scale across the network in a timely way. What is more challenging is to ask questions that require repeated iterations over the data, say a machine learning convergence or a maximum likelihood estimate that has to converge, because iterations over federated data are problematic. And the opportunity of centralized analytics is that you're then able to ask really exploratory questions that can involve many, many, many iterations over the data in one place, perhaps even in memory, which is going to be more effective computationally. So you can ask questions like not whether drug X is good for you, but what drugs are good for you and what drugs are bad for you, and what labs are predictive of various outcomes in a circumstance or situation. COVID, of course, being the immediate example. Next slide. We went through two there. There are phases along this process. We have an initial beginning point with governance and partnership. We recognize that sharing data is a political process, a social process, cultural process with deep obligations to patients, to privacy and security. So we started with governance and also engaging the data communities such as ACT, Trinetics, PCORNet, and OMOP. We then moved on to characterize, well, what kind of questions are we going to ask of these databases to generate the information that we would aggregate and centralize. Once we bring it to the NCATS cloud, we have to harmonize it. It comes from very, very different models, and then engage in a team of collaborative analytics, which is really where this team science experimentation starts. And I'll expand upon that, including derivatives of synthetic data that would have lower barriers for distribution. Next slide. So this is a pipeline, if you will, of processes, activities. We call them work streams that all work together. And I might add, these were all conceptualized, populated, created, actualized, and implemented in about a 4-month period. We started the entire process mid-April, as you might imagine, given the exigencies of COVID and its emergence as a pandemic about that time. In addition, beyond collaborative analytics, as I said, we have the derivative synthetic data, but we also have a nascent work stream that's only formed in the past month on implementation. It's one thing to discover information about associations and risks. It's another thing to bring that data and information back to practice, which is what the implementation focus, obviously focusing on COVID, is working to emphasize. We're working with people like Chuck Friedman at Michigan, who's one of the senior leaders in implementation science in healthcare today. As in everything else, we're enormously gratified by the efforts of the community and the contributions of the community to contribute at every step along these pathways and pipelines, not the least of which is implementation science. Next slide. Back to governance, John Wilbanks from Sage Bionetworks was one of the original PIs of the Center for Data to Health. N3C is really a project within the Center for Data to Health, which is the coordinating center for informatics across the CTSAs. I'm also a co-PI of that program, as well as co-director of the N3C itself. But John is also working on the All of Us campaign with NIH, which is the 1 million volunteer genomic patient population that is being generated across the country, and thus has deep experience in partnerships and governance related issues. He articulated that the goals really were to develop the partnerships with the organizations contributing the data and their IRBs, a common data use agreement, which has been done, and establishing a data access committee. There are myriad other details and documents. We have approximately a dozen consortium-related documents that emerged from partnerships and governance. I will not bore you with them, only to point out that it has been a labor of love, but nevertheless a tedious effort to satisfy all communities in terms of openness, transparency, access, while at the same time protecting privacy, confidentiality, and our fiduciary responsibility to patients and their data. Next slide. Among the issues that the governance undertook was the notion of a central IRB. Our overarching goals for the sites that contributed data, most of the CTSA sites, was to make it as easy as possible for them to participate, which is part of the reason why we leverage the existing data models like PCORNet and OMOP, and why we created a single central IRB. As you can see, Hopkins is the central IRB. I happen to be PI of the protocol, and we've invited other organizations to establish what are called reliance agreements through the SMART IRB system. SMART IRB system is something that the CTSA and NIH established a few years back to simplify the paperwork and logistics and overhead of operating a central IRB and establishing reliance agreements. Once you've established a SMART IRB relationship, you don't have to go through a lot of the effort over again. Again, consistent with our goals of minimizing effort on the part of the contributing sites. Next slide. By the same token, our other work stream next in the pipeline, phenotype and acquisition, worked with the data model communities, OMOP, ACT, PCORNet, and Trinetics, to write queries for the cases and controls that we wanted to pull from their repositories so that the sites didn't have to figure out what query to execute. We literally hand them scripts that define the phenotype for extraction. We also hand them scripts that will package the outputs and results appropriately, Python scripts, the other scripts are SQL scripts, so that the manifest is generated of counts and characterizations and dates and various other metadata about their contribution, and that the file names are in the right case, in the right order, with the right file types, and put into the right folders in the zip folders. These things matter because when we're trying to unpack these things at scale, with updates coming in weekly across 60 or maybe even 100 sites, it doesn't do to have to stop and figure out if they've missed a comma or a semicolon in their scripts to generate the data. We want this to operate as smoothly as possible. And also, again, I'm repeating myself, but it's an important point, to minimize the burden on the contributing sites. So those zip files that are generated through these scripts of the extracts from the common data model elements are then sent to an NCATS central server that is secured by FedRAMP specifications. Next slide. Now again, this is a non-trivial process. So what the phenotype and acquisition team has done is set up what they call a white glove service that includes office hours, that includes webinars, that includes chats, that includes one-on-one consulting and engagement, helping sites go through the regulatory paperwork, helping sites execute the scripts and codes that are necessary, helping sites choose which data model they might. I mean, a lot of sites have both OMOP and PCORNet and ACT and maybe Trinetics as well. So which is going to make the most sense for their site? Extracting the data and ensuring that it can be sent on to the N3C repository. Next slide. Now, recognize that the data is coming to us from these 4 separate data models. These data models are not the same. They don't have the same semantics. They don't have the same structure. They don't have the same bound vocabularies in many cases. So there's a significant harmonization process across these communities. And I want to emphasize that members of these communities have been Herculean in contributing to the process. They've not been in any way defensive or with not forthcoming. The contributions in time, energy, effort, intellectual depth that these communities have made to the N3C project is extraordinary. We could not have asked for greater, stronger, or deeper, or more willing contributions to a shared effort. Next slide. When we get the data, and the we here is actually the Hopkins team. The Hopkins team leads the data harmonization work stream, among other things. So the zip files over on the left are unzipped, reconstituted into their native data model elements with data quality checks done across them. The data quality dashboard, which is an Odyssey OMOP tool, was chosen as our primary data quality machine, but the parameters and elements within it actually are a hybrid and synthesis across all the common data model communities. Every common data model community, again, Odyssey, OMOP, PCORNet, ACT, and Trinetics, confront the challenge of verifying and validating the data that they're given. And they've all established best effort techniques. And what we've done in N3C is try to synthesize those best efforts and best practices into a common framework of our data quality dashboard. When we complete that process, we have what we consider to be a validated common data model from that site for that distribution. So these things permute out. They become problems of engineering scale. And we've leveraged, at least initially, the Adeptia workflow platform at NCATS to conduct this kind of repetitive, meticulous work, establishing pipelines that we can channel site data through at scale. Next slide. Once we have the reconstituted common data model instance, we have to transform it. And again, we use Adeptia to do this. We've chosen OMOP 5.3.1 to be our target data model. It's not practical to have a data repository made up of hybrid data elements and models. They need to be harmonized into a single model. And the harmonization target that we've chosen is OMOP for a very large variety of reasons, most of which has to do with the maturity of the model, the maturity of the software, and the size and scope of the community contributing to it. We repair data that isn't fully formed, particularly COVID codes. Not everybody is correctly encoding COVID test names with the appropriate LOINC codes. So based on text descriptions, we sometimes recode that data to ensure that it's usable in the N3C. And we leveraged a very large library of pre-existing work. This is one of the principles of the N3C. We're shameless about leveraging pre-existing work. We recognize that everything that needs to be done cannot be done by a small team at N3C in the time frame that is needed and that actually happened. And the reason we were able to ramp up and achieve what we've achieved so rapidly is precisely because we've leveraged the prior work of many, many communities, giving attribution and acknowledgement, we hope, as completely and transparently as possible, but very much standing on the shoulders of previous work, including much of the previous work in these data model communities. Next slide. When we get the OMOP versions of each data set from each site, we then merge it into a single instance of OMOP 5.3. That is, if you will, the analytic data set that would be sent to the environment for analysis. We'll talk more about that later. But this is all happening in a FedRAMP secured environment and then transferred into a data enclave. Data enclave is a term of art, and it implies that you cannot take data off, and that's precisely the reality with a Palantir data enclave. You cannot download data of any kind in any form. This has actually become a bit of a problem as we try to get results off, and we're looking at workarounds to solve that pragmatic challenge. But in the meantime, no data at all can be downloaded from the enclave, although analytics can be conducted on it. Next slide. And this brings us to the collaborative analytics workstream, the next in our flow of work streams. You can see we have an analytic environment, the enclave itself, in which is a spectrum of software. You'll see in that second tier familiar friends like R, Java, Python, as well as the complete Odyssey tool set, other tool sets out of the translator community and the CTSA community like LEAF, natural language processing tools that we used internally to, for example, recognize the test names for COVID tests, as well as MDClone, which is a commercial organization that generates synthetic data from underlying source data and is one of the solutions we're using for synthetic data generation. This all works at scale on a Spark architecture. In the Enclave, it's blazingly fast. It's very dynamically equipped. We've had no performance issues on very large data sets so far, and it's proving, we hope, something that can operate when the full weight of analytic communities populate that environment and use the resources to do the analysis as we expect. This is led by Justin Guenay also at SAGE, along with John Wilbanks, and Joel Saltz at Stony Brook, who is a chair of a department of informatics there, as well as a pathologist and computer scientist with deep knowledge in machine learning methods as they pertain to this environment. Next slide. Now, it's important to understand that we have many levels of data within N3C. We'll start with the pink side of HIPAA-limited data sets. That is what you know it to be. It is data that has full and actual date information, which is considered a kind of identifying information. It has full 5-digit zip codes, but otherwise has the other HIPAA data elements removed. A limited data set is considered an identifiable data set, but this is what we are asking contributing sites to send us. So it's very gratifying that virtually all of the CTSAs have agreed to send us a limited data set of their COVID patients, even though they all recognize the risk, and we are working to mitigate that risk with data enclaves, attestation, agreements, and of course, oversight to the degree that would profoundly mitigate that risk. That being said, most investigators cannot access the limited data set. Most investigators are given access, depending upon their protocol and their project, to the derivative of the limited data set, which is moving to the left in the yellow space of a safe harbor copy. The safe harbor copy, of course, truncates zip codes, shifts dates, and otherwise de-identifies the data more fully than a HIPAA limited data set. No data set is ever fully de-identified. We recognize that, which is why we are pursuing research and exploration of the synthetic data. That is a fully synthesized derivative of the limited data set generated by essentially sampling from the distributions of the data. So if a laboratory value has a given Gaussian distribution, that is statistically modeled, and the synthetic data set is generated by sampling from those distributions. It does so further in a way that preserves first order and to some degree second order interactions. So if your hemoglobin is low, your hematocrit better also darn well be low to be clinically concurrent. And those are the kinds of relationships that are preserved in the synthetic data, making it capable of sustaining some analytic exploration that can be subsequently validated on the limited data set if need be. Next slide. So some statistics of where we are as of midweek. This was, I guess, on Tuesday. 59 sites, remember there are 60 CTSAs, have executed data transfer agreements with NCATS. Not all of those 59 are CTSAs. I believe 2 of them are not. But that means that so far, the vast majority have executed. And I think the others were waiting for the data use agreement to be published because their internal legal department wanted to look at the DUA before they signed the DTA, the data transfer agreement. The data use agreement is used to access the data for analysis. The data transfer agreement is used to authorize the transfer of data from the site to the N3C enclave. 43 sites have an IRB approval, and I actually saw 2 more come through this morning, so I happen to know that's 45. 41 sites have met with the data acquisition group to begin the data transfer process, and 26 sites, or so almost half, have actually deposited data already on the N3C pipeline. Now remember, we began in April with this as an idea and exploring the political, cultural, legal issues, which were all daunting in the governance of this process. So to have about half the sites in the country contributing data to the pipeline as of 4 or 5 months later, we think is gratifying. You can see a very ecumenical distribution of data models there, of almost equal distribution of people that choose to send OMOP data sets, Trinetics data sets, ACT data sets, and PCORNet data sets. 19 of those 26 sites have completed the initial data quality review, which means they're in the final preparation and sort of data cleansing processes. And 11 of those sites have actually been put into what we call a data release. This is up from 8 sites last week. We expect it to be 26 sites in a couple of weeks, and ideally it will be 60 sites in a month or so. The release sets are actually what analysts can see, what the public that have gone through the review and approval process in terms of accessing the data can actually see and access. And it's important to recognize that N3C is truly a village. On the right side there, you can see that there are almost 1,000 people that have registered to become members of N3C, representing several hundred organizations across the country and with some international participation. So we're very gratified with the engagement and the participation. And I might add that these 800 odd people are not merely signing up for a fan club. They're contributing effort, participating in meetings. We probably have on the order of 100 meetings a week of various types in terms of analytic teams, data teams, infrastructure teams. Obviously, nobody can attend all of them, but it has become an impressively large process, people working furiously to generate the national data set that we as a country and frankly the world needs to more deeply understand the COVID pandemic process. Next slide. Oh, and just to, this is a Hopkins Grand Round. So we are at a little off in translation there. We are at PCORNet. We were one of the first sites to contribute. No surprise given our role in the process, but we're on that map. Next slide. So what's there? Right now, we have data, it says for 1 year. I think it's been revised to actually be 2 years. We get electronic health record dumps through the common data model filters on observation, specimens, visits, procedures, drugs, I mean, the usual suspects. And it's very rich data, very detailed data, very large amounts of data. Our inclusion criteria are, as you see, basically lab confirmed positive, lab confirmed negative, suspected positive, and possible positive. This is the phenotype that Emily Pfaff at North Carolina, who leads our data acquisition group and phenotyping group, has worked with her communities and the common data model communities to generate. What we have in the enclave today is a modest beginning. We have about 500,000 people, as you can see on the right, a little shy of 30,000 cases, and regrettably almost 7,000 deaths, about 270,000 lab results. So it is not the world's largest database yet, but we fully expect within a month or two for the COVID cases to break 1 million and for the persons to be perhaps an order of magnitude larger than that as we have appropriate controls and negative persons from a large number of sites with significantly larger amounts of information in labs and clinical observations. Next slide. We also have complete drug information as well. In the collaborative analytics team, you can see that we have what we call task groups or task teams. And this is actually an old list. I think there are over 20 task teams as of yesterday. But things like acute kidney injury, critical care, social determinants of health. Hopkins investigators are deeply involved in many of these initiatives. And indeed, Hopkins investigators have initiated an initiative on pharmacoepidemiology that isn't even on this list, where and this is where the social experiment comes in. The N3C had two ways it could operate functionally. We could open the enclave to groups of investigators that would go through the approval process and get access, and potentially have 1,000 papers generated on acute kidney injury. That's not what we really were aspiring to do. We don't want 1,000 papers on any topic. That's not necessarily the best science. Maybe if we had half a dozen papers on acute kidney injury initially, where each of those papers was generated by a team, a multidisciplinary team of clinicians, of data scientists, informaticists, statisticians, working collaboratively to generate the best possible paper that they could. Our first paper had 185 authors on it, and it's our aspiration, that was our methods paper describing what N3C is, and I'll show you that a bit later. And our aspiration is that each of these task teams will create a community where each of their papers will have scores of authors, maybe not 185, but at least scores of authors to truly represent the depth of thinking and the spectrum of skill and knowledge that exists across the country. And this is why it's a social experiment. To my knowledge, this has not been widely embraced of pursuing team science. The advantage of the N3C is that it is an ideal ecosystem in which team science can thrive fairly with attribution and fairly with best science moving forward. Next slide. And this is just to show that we're bringing in capabilities from the NCATS translator community. This is a full CTSA effort, if you will. This is an example of basic science data that can inform protein roles that are played in the metabolism, or at least the impact of the COVID organism, and potential drugs that might be predicted on the basis of the pathways so implicated, drawing from the clouds of ontologies, knowledge resources, data sources above. And this information is being integrated from drug to phenotype into the N3C environment. Next slide. It's important in a social experiment like this that we do track provenance, transparency, and attribution very effectively. The unreadable slide in the lower right with the color-coded red data sets, those are actually data sets, and the yellow data sets shows permission attributes for a given user. The left side, the red side, is actually limited data sets to which they do not have access, but the yellow side are derivatives from themselves or other groups to which they do have access. And each of these data sets has complete provenance and attribution. So who contributed what can be very, very clearly and directly traced as we engage in the team science. And of course, the results are on the most right-fold side, the kinds of tables that would be downloaded for a paper with complete provenance trails of who contributed to that and when and how made. You can see that we invoke the contributor ontology communities and roles as a way of documenting this and managing this with ORCID IDs representing individuals and contributors to the actual process. Next slide. As I said, this was our initial paper. We're a little miffed at JAMIA, who only put the first 3 authors, the 2 corresponding authors and the senior author, on the temporary preprint. But as I said, there are 185 authors, many of them masthead authors, and the rest of them consortial authors. But the point is, we tried to walk the walk when we engaged in this process to acknowledge as many people as deserve to be acknowledged in this process. Next slide. So N3C is open for business as of the 2nd of September. There is a frequently asked questions site to which you can get access. Next slide. The way it's done is for you to register at N3C, have your organization sign a DUA. Hopkins has already done so. For you as an investigator to submit your data use request, the DUR, be reviewed by the Access Committee and conduct research. Next slide. You'd actually start by acknowledging the data use and privacies. You'd have to agree to these conditions, which we think are generally accepted principles. You're not going to try to re-identify individuals or sites. You're not going to download the data. You can't download the data anyhow, but you still have to attest to these things and basically behave as a good peer researcher in the community. I won't get into sanctions or governance, but it is a closely monitored environment. Next slide. Once you've done that, you can begin the registration process. Here's the URL. It's very easy to Google, and you can see at the bottom the Access the Enclave click here button. Next slide. Once you do that, you're taken to a first-time user or a returning user. This is where you register as a member of the N3C community. We collect things like your ORCID ID, your institution, some demographics, your email, and it has to be your institutional email, of course, because your access to the Enclave is actually done through institutional credentials, your JHEAD here at Hopkins. Next slide. Once you do that, you can then log in. As you can see at the top there on the right, log in with your existing account. That is your JHEAD credentials. You have to pick Johns Hopkins as the organization, and then you can then use your regular JHEAD accounts to access the Enclave. The login.gov account is for citizen scientists in the future who are not affiliated with organizations. That's not germane to us for the moment. And then, of course, internal NIH users. Next slide. When you arrive, you'll be greeted by the splash landing page that shows the current status of the data set. This slide is a little dated. There are only 9 sites contributed at that time. But this is where you'll see the button for the data use request and how you can go further, because you can't get much further than this page without authorization to access the data that is granted by your data use request. Next slide. In the data use request, you'll be asked to fill out a number of questions. Next slide. If you are the PI of a project, you'll create a new project title, describe your project as text. This will be read by the Data Access Committee, and it will be published in the community so that everybody will be able to see whose projects are doing what. And if the data does require de-identification or a limited data set, you'll have to do an additional step. Next slide. And that additional step is if you're accessing a limited data set, you actually have to have an IRB locally. Otherwise, you can get de-identified data. You have to attest to your human subjects training, and you have to complete information and security management training at NIH, and there's a link to do that. It's fairly easy to do. But it is a step that has to be taken. Next slide. As I said, if you are requiring access to the limited data set, then you need to have your local IRB justify, and in this case, it would be the Hopkins IRB, as a second IRB, not the central IRB. But if you need access to the limited data set, you need to have your local IRB attest or agree that the scientific justification for you to get access to actual data information and actual location codes at the 5-digit zip code level are scientifically justifiable. This isn't very hard in the context of a pandemic. We think this will be almost a pro forma review, but nevertheless, you have to upload your IRB approval letter if you want to have access to limited data sets. Next slide. We expect the vast majority of people, and I neglected to mention that you can name your co-investigators at this site or at other sites that can partner with you in this process. And we have many DURs that have already gone in as teams and communities. A preferred model, if you don't know anything about it, is to review the existing projects Unfortunately, this slide says public test, public abstract, here's my statement, test. I mean, this is obviously not real information. But this is what the page will look like as it's being populated with real projects. And given the social nature of this effort, we're hoping that, you know, if you're interested in acute kidney injury, you're not going to start yet another project on acute kidney injury, but would work initially with a community that's doing the acute kidney injury, participating in their meetings, looking at their web spaces, looking at their enclaves and their data models to see how you can contribute and participate. Not to say you can't rise to a leadership level or perhaps even to a first authorship in those communities. There is ample opportunity, but we think you're going to go further. You know, it's the old story, if you want to travel fast, travel alone. If you want to travel far, travel together. And we're trying to emphasize that spirit of high quality science, still done quite rapidly. Remember, we got our first manuscript out from just a thought in our air to, in our head, to a complete manuscript describing the environment in less than 3 months. Next slide. And this is just your homepage so that you'll know what projects you're participating in and what data accesses that you've actually been granted as your role in the enclave. Next slide. This is the fact sheet that we create with each release set. This is release set number 4. We've been at it for a while. Obviously, there were no investigators before the 2nd of September, but we wanted to make sure the machinery was working. So this is a characterization of the data that's in each data set. It also includes curated variables, what variables have been normalized, additional information and detail that investigators would want to know. Next slide. So there is a support desk with complete help and support. We recognize that this is going to be disorienting to new investigators. It will be like second nature a week after you've started using it, but there's always that ramp up time. There are support office hours, as well as the support desk and FAQs and a video tour of how to use the enclave. Next slide. So just recognize that these resources are actually quite rich and available to the entire investigator community. Next slide. There are, for those organizations that are interested, Hopkins is already all over this, but we've created newsletter templates, a web page builder so that you can, in your own ICTR site or your own CTSA site, put in information about how investigators in your organization can access the N3C and what it is and how that would happen, and a lot of NCATS communication guidance that is generalizable to many, many sites. But at least here at Hopkins, we're on this, so to speak. Next slide. We urge you to join the N3C community. The processes are straightforward. We think it's we know it's a large community. We hope it will be successful. And the processes to do so are fairly straightforward, and we think anybody can do it. Next slide. So with that, I think I have some time for questions.
Thank you so much, Chris. That was a beautiful presentation. We do have an extremely large and very active community asking many, many questions. So let me pull one of them. Okay, so one of the questions we have, Chris, from Suma Subarao. How are analytical questions prioritized for research, and how can any data scientists or teams participate and submit the research, which you sort of touch on that, but the prioritization, it's interesting. Is there anything of that happening?
The N3C leadership, of which I'm a member, by design has a very light touch. We don't prioritize anything. All of the analytic teams are self-organizing. All of the analytic teams have access to the data. What we are doing as a community is trying to pre-compute variables that are of utility. For example, temperature came in Celsius, it came in Fahrenheit, it came in units that were obviously Fahrenheit but labeled Celsius. I mean, there's a lot of data junk that needs to be fixed. And we as a community are in the process of fixing those data elements, and then creating a derived variable or a cleaned up variable, if you want to think of it that way. Similar with the 57 varieties of serum creatinine. I mean, which one do you use? Well, we're aggregating the ones that make sense and creating a single blood creatinine measure that is usable for analytic purposes with normalized units of measure. Units of measure are sometimes different, and that's problematic. So this kind of normalization work any investigator can use, but in terms of whether they are prioritized or not, quite frankly, it's a function of what the investigators in those task teams choose to do. There is one, I take it back, there is one prioritized project, and that's what we call our cohort paper, which is our second anchor paper after our methods paper, where we will overview the data elements that are in N3C, describe it clinically, describe it from a data content perspective. And we are prioritizing, normalizing the elements that will be used in the cohort paper, but those elements can be used by anybody as we normalize them across the community.
Thank you.
Thank you so much for the great lecture. I was struck by a few things. I guess the question I want to pose to you is, bringing data together from multiple hospitals is not new. We have had common data models for decades. And yet, this is really an unprecedented time. And I have never really seen before an initiative to try to combine the common data models together. And so it feels like not only are you solving a key problem, but you're also advancing the field of informatics. I kind of saw like 3 points that you're advancing the whole field. One is in this whole area of semantic governance and how you're able to bring a community together and to be able to share data so quickly. 2 is this idea of normalizing the data models, normalizing the normalized data. And then the third is it seems like this idea of really trying to advance the science and synthetic clinical data down to second order effects. Do you see those as the 3 areas you're pushing the field forward, or do you see there are others as well?
Well, I think, frankly, they're side effects of our overarching goal. And our overarching goal is to make data about COVID available to as large a community as we responsibly can, with the aspiration that as a larger community, we'd be able to analyze it more quickly and more effectively. The byproduct of that is all the 3 things that you said. We did not set out to achieve those 3 things, but we are achieving those 3 things. And you're correct, Paul. To my knowledge, and sadly, I've been at this game a while, to my knowledge, the N3C is the largest, or will be the largest, consolidated data set of patient record data in the country available for research. There are quality data sets and insurance data sets that are larger, if I'm to be honest, but I don't think they have the depth in terms of the electronic health record data. And I know that they don't have the access to the research community that the N3C will have. So we are moving in unprecedented space. And that, frankly, sociologically has been enabled because it is COVID. We hope to prove that the sky does not fall with such a resource available to the community, and that we are establishing a precedent to potentially broaden this in post-COVID times to national repositories of data for research, leveraging electronic data. CTSA has always aspired to be a network, and I think we are facilitating that realization. As you say, not that there haven't been active federated networks, but consolidating all the data into a single model in a single place is qualitatively different, and quite honestly enables qualitatively different types of analytics than can be done in a federated environment. I'm going to sneak in an answer to one question. I'm glancing at the chat here. Are Hopkins investigators involved in this? The answer is heavens yes. I've been knocking on doors and pulling people out of their offices, metaphorically, to put this in front of their nose, and they've been pleasantly surprised. Initially, they're annoyed, of course, to be interrupted, but I think uniformly, they've been pleasantly surprised. So yes, we are getting a growing cadre of senior investigators and junior investigators becoming aware of N3C and becoming involved in the process of participating in task teams. Brian Garibaldi is one of the prime operators on our cohort overview paper. And as you know, he's the principal investigator of the Crown Registry here at Hopkins. Scott Zieger's team, who contributed enormously to the analytics. Many of his junior faculty are getting deeply engaged in N3C analytics and participating on a number of teams. So, and frankly, the reason we're giving this grand rounds is that so a broader spectrum of Hopkins investigators can choose to become engaged in this process. I've tried to outline as simply as possible, and it's not a hard process, how you can become engaged. And I would urge you not just to sign up and try to go off in a corner and do some analysis, but to actually find out what groups are related to your interests. As I said, we have over a score of groups created. They may not fit exactly, but it will help to get oriented. And then if you have a more specific subset of that, then there's no harm breaking off and creating a new task group. But I would urge you not to try to be a solo cowboy or girl in attempting to approach this data. It's formidable. I'm sorry, back to you folks.
No, thank you, Chris. Thank you. And actually, we're going to have Brian and Garibaldi soon in one of our next grand rounds. So we will know about his work as well. Chris, I have a question. Look, it's actually two questions from the students, and I'm going to try to put them together. So COVID has been really unprecedented, as we all say. Now, there have been some efforts that have been great and I think have surprised the community in general. And one of those efforts is the rapid development on the vaccine area. And then the second effort is how quickly this architecture of data has been built, not only in the US, but internationally, right? With examples from Britain and some other places. So the two questions I have from students is, one, from Ting He: will this pipeline be useful for the next new pandemic or infectious disease outbreak we could have? That's one question. And then the second question from Samir Balodia is there any plan to collect international COVID data or collaborate with these international friends?
Yeah, both excellent questions. It's no accident that the infrastructure we're creating was leveraged from generalized data models and methods that were not COVID specific in any way. The OMOP community, the PCORNet community have been, as Paul said, operating a decade or more in some cases. And we are leveraging general methods with the explicit intention that if we are responsible, and as I say, the sky does not fall, we can expand, we'll have to change the name, I guess, of the N3C to something that doesn't include COVID. But we can expand this to a central repository for observational research. Real world evidence, I think, is the fashion phrase this week, of clinical outcomes for a variety of cases, not just pandemics, but chronic diseases, other kinds of diseases, drug disease interactions. I mean, there's potentially no limit if you confine your thinking to observational data. Obviously, we can't do randomized trials in this environment. It is purely observational. But in the context of leveraging observational data, we can generalize it hugely. On the international question, we have been, our initial aspiration, we had a lot of conversations with the European Union, with people in the Pacific Rim and Australia about participation and collaboration. And we as investigators are very much open to that. There are, how do I phrase this? We're being recorded, I understand. Forces in the administration to remember this is an NIH funded effort, and NIH reports to HHS that reports to another place. And our ability to engage foreign data sets in N3C is, for the time being, restricted. That's not to say that we don't have an aspiration. That's not to say that those organizations are also familiar with our open public common data models and could not theoretically engage overnight if that was permissible. We have allowed investigators from Europe to access the N3C. That was a special dispensation, but for reasons that are quite frankly political. Other parts of the world are not yet able to access the N3C environment.
Great. I wanted to have a small comment and then I have a question. My comment is, I think this is super exciting. And what we're seeing now is many publications are rejecting papers unless the data is coming from multiple institutions. And I think this is incredibly important, especially when it comes to machine learning. There's a lot of biases you get from your local sources. And so I think a resource like N3C is critical for people who are trying to conduct research and then trying to generalize it for a larger group. So I think this is going to become, I think hopefully you'll have a lot of customers coming to you to create new evidence around this. But my question comes from Josh Gray, who's a medical student here, who had a great question. And you mentioned a little bit about data quality, and that's a big topic. Yeah. And you mentioned that you can fix some stuff downstream. You can see, hey, that's not Fahrenheit, that's Celsius. But at the end of the day, you're going to have to take what's coming from these hospitals. And you showed us the data quality dashboard, which ran over 3,000 different tests for completeness and for conformance and plausibility. And so I guess the question to you is, are you giving report cards back to the health systems that are submitting data to you? I know you're saying, thank you so much for your data, but are you going to give them some suggestions on how to help improve the quality of their data for clinical research purposes?
We have long, frank discussions with our contributors almost daily. You know, data quality is asymptotic. You never really achieve it. But we are giving, and some of the data quality issues that we ran into were, in our terms, fatal, in that we just couldn't move the data set forward. It was just too far gone. So yes, we are giving them more than dashboards. We're giving them, to the extent that they're willing to engage. And I might say to a site, they've all received our criticism, if you want to think of it that way, and observations very constructively and very positively, and have been eager to address what they can. You know, sometimes they're downstream of other sources. They have what they have. We recognize that, and you know, we do our best to manage with the data that we are given or that they have been given. But yes, we are deeply involved with data improvement as a proactive process with all of our contributing sites. And in fairness, the phenotype and both the phenotype and acquisition group and the harmonization group, that's a major component of their effort, is working with sites to improve this data. In terms of overarching data quality, let me be clear, let me make a final point. We are at some level a least common denominator data set. We recognize that trying to merge data has challenges. Some of the data models are richer than others. That is simply a reality. You can't get blood from a stone. If it's not in the data model, we're not going to get the data element. And we're publishing, you know, what are the systematic issues by data model in the N3C, so that investigators don't go nuts saying, well, you know, site XYZ doesn't have whatever, and well, they don't have it because it's not in their data model. And you know, let's move on. We will never achieve the quality of a data registry like the Crown Registry at Hopkins. We recognize that. The Crown Registry at Hopkins has been very, very deeply curated. Paul, I know you led many medical students in managing the abstraction from records, from flow sheets, from other data sources, manually curating that data in Crown so that it is more complete, more accurate, more reliable than most other data sets in the institution. We will never achieve that level of credibility and data quality in N3C, nor quite frankly, is it our aspiration to do so. Now, we may get there slowly over time as other organizations and other data model communities work to integrate their data and improve its quality. And our boat will rise with them. We are not making backdoor efforts to get the Crown Registry into N3C. We want to work with the data model communities so that all boats rise together as we collectively try to strive for as completed data as possible. I see we are at time. Is that true?
Yes, yes, Christopher. We're on time. We had many questions. We appreciate your presentation. We thank you very much. And with that being said, I'm going to close these grand rounds. I'm going to make the formal invitation for the next grand rounds in October 8th, where we will have Dr. Stuart Ray from Johns Hopkins Medicine talking about clinical metadata in pandemic response. So thank you so much, Chris. Thank you everyone for your great questions, and we look forward to seeing you in the future.
Thank you.